Hi everyone, are you able to hear me clearly and see the screen clearly? Great. Um, Hi, could you mute yourself, Alok? It's unmuted again. Okay. So the way we generally work is that except for the instructor, which is me, everybody is muted in these sessions. And in case you have some questions to ask, you can ask using chat. And if the question that you want to ask is something that you are not able to type, then you can unmute yourself by telling the people in the chat that you're going to unmute. Okay, great. So hi everyone, are you able to hear me clearly and see my screen clearly? Great, great to have all of you in the session. All right, all right. So should we start? All right. So till the last time, what we have learned was how to create an RDD from a file. All right. All right. So whatever is the script, I'll be sharing it with you. And then, okay. Okay. All right. So till the last time, what we have learned was that the basic construct of Spark is the RDD. RDD is nothing but an array representation using multiple machines. Okay. So we will code or we will write our code against the array, against the RDD. So we first need to create an RDD. All right. So unlike the usual way, unlike the usual programming where we have where we generally write the for loop, while loop, main method, the here in case of solving big data problem, the data comes first. So first of all, we need to create an RDD and then operate on that RDD. All right. So just like in databases, before we start the story, we create tables. Okay. And then we operate on those tables. In the same way, we create distributed array or RDD, resilient distributed dataset. And the common construct is we use a function called text file here. So if your data is in the form of text file, then you can use the text file function. Here, what we're doing is we are using sc.text file in order to load this. Okay. So let me show you. And the way you start is using Spark shell. Okay. Using a Spark shell, we have started the Scala shell, which is connected to the Spark. And what does it mean by connected? It has created two variables, sc and SQL context, which are our gateway to the Spark. If we launch Scala uh, if we launch Scala normally, then we won't have these two extra objects. Also, any Scala code can be written here. All right. So what we're doing is we are writing this. Also, when we are when we are not doing the Spark programming interactively. Right now, this is interactive way of computing. When we are not doing Spark programming interactively, we might have to write a program which we'll submit. In that case, the SC, the Spark context, we have to create by ourselves. Right now, Spark Shell has created this SC object, which is our gateway to the Spark. Otherwise, we'll have to create this instance by ourselves. Okay, we will learn that soon. So what is it that we are doing here? We are saying sc.text file, and we are passing the URL of the file. URL of the file. Okay, let me just give you the code. Okay, so let me just give you the code. It doesn't work. Okay, let me copy it again and give it. A question from Bintao is, can we practice Spark within Jupyter? Of course. Okay. So you can actually go here and go to Jupyter, and in this view, we could say new and say Apache Tori Scala. It will take some time to execute. Okay. Let's just try this. In case this doesn't work for us, we can go back to the console. Sometimes it doesn't work for me. Okay, and we are yet to figure out why is it that it's not working for me in the Jupyter notebook. Okay, see, it's taking a lot of time to execute. Right now it has done the execution. Let's just take a look at what's going on. So you can see that it has created lines. Lines is our RDD, and this RDD is nothing but a representation of this command. This lines is an RDD which says that this lines is mapped to this text file, which is in HDFS. Okay, so we can say lines dot, I think describe work. No, it doesn't work. I'll we'll talk about here. So there are many functions provided by this, and okay, we'll talk about the describe again. It's called toDebug string. Okay, so toDebug string is nothing but it shows that how is this lines created. Okay, also the RDD is a lazy object, as in lazy way of doing computing, because when we say lines equals sc.text file, it has not loaded the data into it. It has just made a note that lines represent this file. Okay, so lines is not something that's loaded. The lines does not contain data right now. Okay, and therefore it's going to do something only when we call an action. Okay, so right now we've just loaded defined our lines, just like defining a function. Unless we call a function, it wouldn't nothing will happen. Similarly, lines has been defined. Unless we call an action such as take or collect or save, nothing will happen. We'll just keep describing the steps. We will not be executing the steps. Okay, so here what you see is lines.toDebug string is essentially showing us the various steps of computation. All right, so this is one way of creating an RDD. The other way of creating an RDD is by the way of converting an in-memory object. This is our in-memory object. It's a range object, you can see. So this ARR is a range object containing all these numbers. Okay, and we can convert this range object into an RDD by using a method called parallelize on SC. Okay, so what you see here is nums. Now nums is a parallelized collection. Parallelized basically it's an RDD which is done using the parallelized. Okay, all right. So essentially, both nums and lines are an RDD, and nums also, if you say nums.take, only then something will happen, right? If we say take 10, it gave us 10 records. All right, should I give you this piece of code? Is it? Oh, all right. A question from Shupratik is, what's happening behind the scenes when we call parallelize, right? So when we call parallelize, it's basically converting this array or mapping this array to this RDD nums. Okay. In case of parallelize, I think it distributes the work immediately onto multiple machines because it's an in-memory object. Okay. Now let's jump ahead a bit. Okay, let's jump ahead a bit and walk you through the word count again. I think most of you were able to do it last time. Okay, let me just give you this. Uh, um, okay, so here, um, this is the function that we talked about last time. Oh, did we? I think we created. Did we create a spread? What do you call? I think we created a okay, we created a book last time. Is it? Did we create this? No. Let me go. I'm just trying to recollect if we created a notebook here last Saturday. Did we create this? I see. I'm just trying to recall if we worked on it last time. No, actually. hmm So actually, we can do that now. What do you say? What we will basically create a notebook which we will sync with all of you so that I don't have to copy paste the code. Okay, so I'm just saying new here. Okay. Mm, let me just see if I could. All right, let me just rename it for you. And we'll call it RDD basics. Okay. All right. All right. Good. Just set it down. Okay, great. So what we have done is we've just created a new notebook. Okay, and in this new notebook, what you notice is um, we are going to start with creating this function. Also, let's launch a terminal so that I can keep committing this file. Okay, how do you commit it? Using, okay, so this is where I've checked out my code and not here, Spark, right? Good. So Git, I'm going to add it, Git add RDD basics and Git push origin master. Oh, we have to also commit it, the class work. Okay. So what we are trying to do, we are trying to commit this code to the repository. Great. So now since we have pushed the newer changes, these changes will keep on reflecting in the GitHub repository. You can simply open, if you want, you can open this one. All right. So here you can see that uh, those who are inclined, so they can take a look at this. Okay. I'll answer your questions in a minute. So here, this is the file. You can just open on GitHub. And as in when I'm committing, it'll reflect here. Okay. So this is the absolute URL of the file. All right. Let me take the terminal somewhere else so that I can keep committing it. Okay. All right. So good. We are all set. I can exit it. Okay. All right. So those who are new to it, uh, is everybody able to open Jupyter? You can either open using a Spark shell or using this new Apache Tori Scala. You see this one? Either this way or using the, all right, or using the console, like here, typing the command called Spark shell. Great, great. So, all right. So there are two questions. One is what was the function to debug string? The function to debug string here, let me again show you. Okay. The function to debug string was, let's say, let me define this. Okay. Let me take it here. Right. And here, when you see this, it's essentially showing the debug details of the RDD. Okay, at any point of time, whatever RDD we have created, we can take a look at the debug string. Okay, so first step, what we did, let me do the word count, and then I'll show you the debug string again. That'll show you all the steps involved in the final computation. Okay, so what we have done is we have defined lines RDD, which is basically loaded from this file, and this file is where? In HDFS. Okay, and why is picking from the HDFS? Because the way we have defined SC, we have informed when we launch by default the default Jupyter notebook, what it does is it launches the it launches this partial version, and it basically defines the Hadoop and everything Hadoop environment variables, and using that it figures out the Spark context. It using the Hadoop detail, it figures out where is name node and other things about the file system. All right, so for now you can understand that when we do sc.text file, it's going to basically create an RDD. It is going to return an RDD which is going to contain elements such that each element corresponds to each line of this file. First line of this file will be first element of this. If you want to take a look at it, what you can do is you can simply say lines RDD dot take one, right? So this is the first line of this file. Okay, if you want to take a look at this file, you could go to your MyLab section here in here. Okay, here, right? Either MyLab or in the services section, either one. Or you could just go to say MyLab here, and there you will notice that there is something called hue. Okay, using hue, we can take a look at the HDFS and locate this file. All right. All right. So you can see that this is the first file, and this is the second file, and so on. All right. Mm, so let me just give me a second. I will just give me a second. All right. Okay, so what we are trying to do is if you go into the MyLab section, you can take a look at Jupyter, take a look at the Ambari, and take a look at the Hue. Ambari is for administering the cluster. Hue is to access the HDFS and other file systems. Web console is to interact using console, and so on. Okay, and in case you want to take a look at the videos to get started, you can use the Learn section. In the Learn section, you have all the videos which basically make you acquainted with the ecosystem of Hadoop and the various components. Okay. All right. So here what we're trying to do is there is this file, there's this file in HDFS. We are going to do a word count on this file. And the way we are doing is we basically are first of all creating an lines RDD that represents this file. Okay. And if we say if it is 10, that means there are going to be 10 lines picked up from the file. Okay. Is anybody else facing the audio problems? Yes, go ahead, Tanmay. Go ahead. You had a question. What are the functions available? How do I look at it? The easiest way to find out which functions are available, just press tab here, and you will know all the functions that are available. Okay, you will know all the functions that are available, and as we go ahead, we will also learn more and more about the functions available as part of the RDD. Okay, great. So what we just learned was using the take, we can take a look at the records of this file. Okay, so each this array is this array when we say take, okay, and we can assign it to a local array. Okay, I've just defined a variable called local array, and this local array is just like normal scalar array. Okay, you can see that this is a normal scalar array. Can anybody tell that um, what is the data type of each value in the local array? That's right. That's right. It is the string. Great. Great. All right. It is the string because you can see that here it's a single character. Now, going ahead with this, now let's take a look at the second function here. Okay. And let me further break it down. Those who are not aware about Jupyter, you can actually click here in this section to get into the command mode and press A to insert a cell before this one, as well as you can press X to delete a particular cell. Okay, so we are saying, let me just add some more here. All right. Now what you see here is we are defining words from lines RDD. Okay. So what does it mean is we are defining words by operating on lines RDD. Okay. And what is it that we are doing here? We are calling a function called flatmap. Flatmap basically breaks down one record into many records. Okay. If so, since this lines RDD has one line per record, this one will convert each line into records, each line into words, and hence this RDD called words will have one word per record of the RDD. Okay, before we jump to this line, let's just define this one and learn what's going on here. Okay, so we could say print words. So this is our words. Now let's take a look at the to debug string. Okay, so it is showing us that first we using text file we operated on this file, then flat map on top of text file. Okay, now let me uncomment the second line here and then take a look at it. Okay, and okay, so what we did was from the lines RDD we created words, then on words we are calling a function called map in which we are converting every record into a pair. Okay, every record. We will go into more details about these steps. Okay, just try executing things with me. Okay, this will speed up the process of learning. Okay, whenever we are learning new things, there is always back and forth between various concepts. And if I keep on explaining the concept upfront, you won't you won't really learn. You will basically keep on getting bored with all the theory. All right. So therefore, it's important to do the things with me as I'm doing. You also try doing these, and that's the only way to become comfortable with any of these tools. Okay. So what we learned just now is words KV is nothing but whatever we have done with words, we have just converted each element into tuples. Let's take a look at say words dot take 10, right? So what will we get here? We will get 10 words from the from the file. If we say 50 words, what will happen? Will it give error? Words dot take. Okay. It will basically show us 50 words from the file, right? All right. Now, next thing is we are saying words kv dot take 10, right? What would happen is it'll convert every record into a tuple. Okay. Let me again show you what happened here. Okay, so that we can compare things head to head. Okay, so we are saying, let me just delete this portion. So so words contain these many records. Words, it gave us 10 records. Also, before this, if I say lines RDD dot take 10. Take 10 means give me 10 records. So it gave us 10 lines. Correct? When we said word dot take 10, it gave us 10 words, which means that this flat map function, what it did was it converted this RDD from each the RDD containing each line as a element, it converted it into each word. Okay. And then when we say words KV10, so now it's very clear to you, correct? So now you can see the difference between flat map and map. With map, you can never convert one value into many values. Okay? With map, we can never convert one value into many values. Okay? Map can only convert one value into another value. You see, the has been converted into the one, project has been converted into project one, and so on. Okay. Those who are wondering what would happen if we had done map? Okay, sure. How can I give you the code better? Okay, save and checkpoint, and I have pushed the code. All right. Uh, who all have cloned the repository? Has anybody cloned the repository? Nobody? Okay, I think it's not needed. You can just open this side by side, that GitHub repository, so that you can keep on copying this code. All right. Let me file download as say text file. Okay, so I've just opened this. Okay, this contains all of the code that I've written in the notebook. All right, so you can actually open the GitHub repository. It would be reflected there. Okay. All right. So yes, we'll talk about the rest later. So now I think it is clear, right? So imagine that here instead of flat map, we will have done map, then it would not convert one line into another line. Should I show you that? Let's say instead of flat map, we did map. Okay. So what would happen is, what what would happen is the words will be an array of strings. Okay. And when we say give me 10 records, it will give me 10 arrays of the strings. Okay, let me show you what's the difference. Now you can see that this is one array, this is another array, this is another array, and so on. Did you notice that? So flat map only converts one element into another, meaning we are converting a string into an array, right? Therefore, we have to use flat map because we want to convert every line into what? Every line into words. Okay. Bintao, did that answer your question regarding the difference between map and flat map? We'll go into more details about map and flat map further, but this was a good exercise to notice and to observe what's happening, because the only way we can learn anything is by trying things out, by doing hands-on, and not by the way of explaining alone. Okay, explaining will make sense only after you've tried things and you are trying to connect the dots back. Only then the explaining will make more sense. All right. Okay. So Alok, are you able to open Jupyter and click on new notebook and Scala from the from your say my if you go to my labs here, okay. If you go to my labs, click on Jupyter, okay. Click on Jupyter, and there once Jupyter opens like this, click on new and click on Apache Tori Scala. All right. If it's asking for login password, provide this whatever login password is paid here, and you will be able to log in there. In case your Jupyter doesn't work or some error is happening, go to the web console, as in click on web console, log in there, and launch Spark Shell. Okay. So a question from Arun. What does it mean by toDebug string? ToDebug string shows you the steps. If you want to debug what's happening underneath, let's say we want to understand what's happening here, right? So what we'll do is we'll say words kv, okay, words kv, okay, and say toDebug. Also notice that toDebug string is a function, okay, and toDebug string is a function, and it can be used this way, okay. Or let me just in Scala you can call the function this way without argument. I'm not sure if it should be a function in my belief. Let me just check later. Okay, so what's happening here is toDebug string on words kv is telling us that there was something called big.txt, right? We converted it into text file, correct? Sorry, we loaded it using text file. Then by using flat map, we broke down it into something. Then we used map. So basically, every RDD, you see, first we created one RDD called lines RDD. Then we created words RDD. From here we created another RDD, and then we created this RDD. Sorry, we created this RDD, right? So when we say this, what's happening is it's creating the entire DAG. It's keeping a track of the whole lineage, whole whole story about the RDD. So each RDD is nothing but the steps involved reaching that point. Okay, so each RDD is not like data loaded into memory. Instead, it is list of instructions. Okay, it is list of instructions. This is called lazy evaluation method, and we will learn more details about lazy evaluation very soon. Okay, but it's very important to notice all of these steps right now, because this is something that will make more sense when we talk theory about the RDD. All right. So this is basically, if you take a look at it, it's basically the scalar object that contains the story, that contains all the step how we reached here. Okay. So if we say words will contain the story up to here, up to here. All right. So that's how it is. Okay. So instead of looking at RDD like a data set, you should look at the RDD like the list of instructions. Good. Now, once we have created the key value RDD here, right? Key value RDD, and what does it contains? It contains tuples. You see tuples? These are tuples. Okay. Every element of this RDD is a tuple. We have said take 10. That's why it has executed the entire steps and gave us the output. Okay. Now let's move ahead. Then we are saying words kv.reduce by key. Reduce by key is essentially equal to grouping the data by key and utilizing this function to add all the values. Okay, so it's like saying group by key and sum up the values for each key. All right, that's what is happening. Key means the first element of this tuple. And what is the first element of this one? The first element of this tuple is project. First element of this tuple is Gutenberg. Therefore, what's happening here is this data is being grouped based on the key. All right. We're going to talk about this in more details stepwise further. Here we are jumping directly into the code so that when we talk theory, you'll get the clear picture. All right. Now, here is an interesting part. So this is where we were last time. So this output is basically again another RDD. All right, let me just take this and sorry. All right, let me just take these two steps. Oh, let me just take these two steps and put it in the next cell. Okay, now here we have again defined another RDD. Okay, this is, let's take a look. It's a shuffled RDD. Okay, if we take a look at the steps, you see, it's a shuffle RDD reduced by key. And so this RDD called output knows that how to reach to the output. It knows all the steps. It knows all the steps involved in this. Okay. Now, either we could say take 10. Okay. Either we could say take 10. Take 10 means it's giving us 10 records, 10 records of the computation, and it shows that it has done the word count for us. Bone, the word bone existing 350 times, AH exclamation is existing 6 times, and so on, right? Similarly, we could also say save the data to my text file. Okay, save all of the records to this text file. Let's just give it a name. I would like to give it a name 23rd December. Okay. All right, I'll just put it .txt just to make ourselves comfortable. So what does this do? It is going to do the computation and save it in this file. All right. So why it took some time to do this operation, right? It took a while. Why? Because here, when we say save as text file or take, this is where all of these steps are going to get executed. All right. So now it has finished the processing, right? Let's take a look at this file. And where will this file be? This file is going to be in the hue, right? And when we do not specify any absolute path, meaning if our URL or the location of the file is not starting with slash, that means it is with respect to our home directory, right? So let's go to hue, click on home, okay, and sort the data by the date because I have just too many files. And here, what you see is this is the file containing, this is the folder that contains our output. Okay, it's actually supposed to be a folder instead of a file. All right, sorry about that. Now you can see that it has done the computation of word count. And of course, it's not really neat because it is having all these words, as in there is, right? This is not clean, right? You can see that. We could do this cleaning up easily by another map. Okay, we can do this cleaning up easily, like converting it to lowercase, removing these punctuation marks like dot and etc. All right, so you can see that this piece of code has done the word count. Is everybody okay? Did it work for you? All right. Is that Raghu, that number 125,741? Can I change your name? All right. Ali, Alok, Arun, Bhuvan, Bintao, Faisal, Gautam, Igor, George, Manoj, Michelle, Mrinmoy, Raghu, Rashmi, Sandy, Sankar, Supratik, Tanmoy, Yograni. Are you able to execute this? Were you able to create this? Let me just change this name. This should have been this way. All right, because it's going to be a folder, not the file. Okay. Question from Arun. Output is in two parts because it used two nodes to execute. It basically used two parallel processes to do the computation. Okay. Okay, no worries. In case you're facing Jupyter issues, you can switch to the command line. So Alok, what kind of error are you getting? Manoj, are you able to do it? A question from Faisal is, can we specify how many parts are created? Yes, yes. So we'll learn that part, okay, soon. We can we will learn how does it work, why these many parts are being created and so on. Okay. Yes. Yes, Gautam, we can do that. There's a bit of difference between Spark and Hadoop notations of MapReduce. Okay, great, George. In the second line, you're getting an error here. Question from Myanmar. Can we talk about parallelize and collect in detail? Okay. Collect basically brings the data back to you, while parallelize converts the local variable into an RDD. So parallelize and collect are kind of opposite to each other. Okay. Parallelize converts local array into an RDD, while collect converts a RDD into a local array. A question from Faisal is there a max file size limit that can be used as input? Not really. Not really. Okay, because it's not going to load this entire file in the memory. Instead, it's going to divide the work amongst many computers when we call take or collect or save. Okay, a question from George is there a function to know the time it takes? A good question. A good question. Probably, okay, actually, yes, this is an important point. So on the, this is the first time I'm using the Jupyter. I've generally used the console. Okay. So on console, when we do something, it generally prints the time it takes. Okay. But here, I'm not sure how to turn it on. I'm not sure how to, okay. I'm not sure if this works. What is the time function, right? Yes, yes, Manoj, it is there in the console, and that's what I'm missing here. Generally, that is printed because in the console, the debug is on. Okay, maybe I can do sc dot set log level, and I say debug. Okay, let me see if it works. No, it did not work. Okay, no, it did not work. So, okay, all right, all right. The No, it doesn't work. All right, so log level did not work. Okay, so I think that's the downside of using Jupyter, that we are not able to see all the debug information. All right. Okay. Point from Myanmar is that in Apache Javelin, similar to Jupyter, you can see the time taken, but not in Jupyter. You can install NB extension to see it or use scalar time function. Okay, scalar time function may not give us the right values because in case things are getting executed on multiple nodes and we want to actually time the real one, then we would like to use the time returned by the Spark. Okay, so probably we'll have to experiment on Javelin. Okay, I see. I see. So I think it's okay to go with the console. I'm kind of okay with even going with the console. Just that here I'm able to share the code quickly, but that's okay. Yes, go ahead, Manoj. Okay. All right. Question from Manoj. Can you revise what these three lines did? So what was lines? Lines RDD? Lines RDD was an RDD of lines, as in each record in the RDD. RDD is nothing but like an array, but distributed, and every record was, what was the every record was? Each line from the file. Then what flatmap did was it broke down every line into array of words. Okay, what the function in the flatmap broke it down. That's what I was describing here. So let me show you. If we say lines.rdd and we say lines.rdd, lines.rdd dot take 10, it gives us 10 records here. Okay, 10 lines. And when we say words.take, it returns 10 words. Why? Because flatmap does that. Flatmap expects the function. This is an anonymous function. Okay, this is an anonymous function. What does this function doing? It's saying that the argument is x in the function, and it is returning argument dot split by space. Okay, so piece of code this piece of code that's converting each line into an array of words is being executed against all of these lines, right? So this function is going to be called again. If there are 1,000 lines in lines RDD, it's going to be called 1,000 times. Okay, and these thousand as a result of this is going to convert every line into array. And what flatmap does is it merges that all the elements of that resulting array into one big array. That means the resultant words is going to contain all of the words. The resultant words is going to be an array containing all of the words from this file. Meaning when we say words.take 10, we are going to get 10 words. Okay, words kb is basically converting. Here when we say word.map, it's going to convert x into a tuple. Okay, meaning this function which converts any value into a tuple is going to be called on every word. That means da will become this, project will become this. If there are 1,000 records there, this function is going to be called 1,000 times. Okay, the function, this is an anonymous function. This is anonymous function, and we are calling this function again and again. The map is going to call this function against every record. Okay, a question from files. Question from Manoj. If the file has 100 lines, so lines RDD will be an array of 100 elements. That's right. That's correct. Raghu is saying the is comma the default word separator. It's just for displaying in the UI. It is just for displaying UI, that whenever in Scala, when you define an array and you print it, it displays it in this way. Okay. All right. Don't worry about this. I'll come back to this in far more details. Don't worry. Right now, let's just try to execute it and get the bit of an idea about things. Okay. All right. Don't worry about this. We will come back in more details very soon. Okay. A question from Alok. The first line this, and second line this, and third line this. I'm not getting any output. Should I do something to execute these commands? Yeah, you have. Okay, let me again go here. You go here and say shift enter, then again shift enter, then again shift enter. Okay. Alok, you can ask this question to everyone so that I don't have to repeat the question. Okay. Instead of private. All right, wonderful, wonderful. So who all are able to get the word count in the file? Nobody? Sankar is done. Manoj is done. Supratik is done. Raghu is done. Wonderful. Faisal is done. Sankar is done. Minma is done. Arun is done. Okay. All right. So let me give you the consolidated code again. Okay. If your kernel is dead, then go to the console and do it from there. Okay. Go to the MyLab, click on the console, then do the Spark shell. Run the command called Spark shell, and from the Spark shell, you just copy paste these lines and it would work. All right. Okay. Does anybody need help at this point? We will go more and more details into what exactly is going on. A question from Alok, which topic today? We are basically getting started with the basics of RDD. A question from Manoj. I'm using console only all this time. Do I miss anything in this way? Not really, not really. I think that's good enough. Okay, I'm actually missing things on Jupyter. So when we do take and collect, the entire process gets executed. While when we're defining flat map, text file, or map, it doesn't do anything. If you don't believe me, try tweaking the name of the file. I just gave a random name, right? This is some random name I've given right now, and it's accepting it. Did you notice that? And when I do something like this, it is going to give me an error saying the file does not exist. You see that? So when we are calling text file or other functions, it is just accepting it happily. Okay. Even let's say here I'm defining all of these functions, right? And unless you see that, so it accepted it happily. And when I do this, then it throws an error. Okay. So flat map are the transformations. Text files is also kind of a transformation, while take and the save as text file is a action. Okay, so when we call an action, something happens, but when we call a transformation, nothing happens. It just makes a note of it. This thank you for letting it's like saying when I call text file, it's just making a note of it that hey, I've called a text file. When you will call take, collect, or save, then I'll do the actual work. Right now I'm just making note of what you're saying. Okay, that's how it is. So when I say flat map again, it's just going to make a note of it. It's not going to do anything. Similarly, map. Okay. A question from Alok, is there any IDE like Eclipse to do, or we have to do in Jupyter or Spark Shell Console? So most of your time would actually go in Jupyter or Spark Console, okay? And only in the final rounds when your work is done, only then you would kind of bundle everything together into a Spark application and do a Spark submit. All right? But most of the work can be done easily from the Spark shell because most of this work is used in data churning, data exploration, and so on. Therefore, most of the work happens interactively. Okay, instead of writing this rock solid code and waiting for the final time to compile and submit, here you interactively code and explore your data and go stepwise. Yes, in the console, it gives you a lot of details about the execution. We will go into more details about those execution in the rest of the class. All right, good, good. Question from Tanmay, how to take care of this type of IO exception in Scala? Yes, Scala also provides you try catch, and using try catch, you can handle the exception. All right. Okay, wonderful. Wonderful. So what we just learned was the how to do word count. Word count is like hello world of the big data world. Okay. Now this is not required, so I'm going to delete it. Wonderful. Wonderful to have all of you do the hands-on. Okay. A question from Raghu. Can we print the total word count in the files? Yes, you can simply say um, things like words dot count. Okay. It's also going to do the count for us. A question from Gautam, can we bypass reducers and use the combiners in Spark? Mm, it's basically reducers is not okay. I'll come back to this. I'll come back to this. Okay, I'll come back to this and then we'll talk about reducers. All right, so using count, you can do that. Let me just um, get this again. All right. And here, so I had to do the whole execution again. All right. So now I can say words.count. Oh, it did not print? Yes, these many words are there. 3 and 3. That means 1.1 million words are there. A question from Manoj. So here, all the processing is being done via array data structure. So here, the processing is happening for unstructured data, right? We do not have the data in a tabular form. As we go ahead, we will learn how to do the tabular structure data. Okay, so what we'll do is we will learn how to okay, so as we proceed further, we will learn how to convert, now how to process data using a tabular format in the Spark data frame. Spark also provides its data frame, which is distributed. Okay, so we'll go ahead, like you can do everything what you can do in rest of the systems like R or 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 SQL. You can do the same thing in this. Question from Michelle: If uh, in Hue, why do we have part first and part two as a result? Why not just one folder? So we have one folder but two files. Okay, because here under the hood it's working in parallel, and part one and part two are being computed in parallel. Had they been writing in single file, then the parallelism will not happen. Okay, great, great. So moving ahead now. All right. Now, how can you get this result? You can basically continuously committing to the GitHub repository. So what you can do is you can go to the GitHub repository here. Okay, and navigate to this place. Okay, Spark here, and then you can see this file, right? This is that file. Great. All right, you can these parts are not required. Okay, I can just say cell all outputs clear. Wonderful, wonderful. So now I've cleared the output, so it should be clear. All right. Is anybody not able to run it? We can just fix it quickly so that we can proceed further. All right. Let me just be here. No worries. Even if you're able to do it in console, that's good enough. All right. Great. Great. So we did a good job of running it. So, all right. Let's move ahead. Now, we have already talked about two kinds of operations, transformation and action, right? And what happens in case of a transformation, one RDD gets translated into another RDD. Okay, so whatever transformation we define, that transformation is going to be called on RDD on every partition or every element of it, and then we will get another RDD. So transformations are operations or functions executed on an RDD. It returns a new RDD such as map, flat map, or filter. Okay, so here is an example of a transformation, right? Say we have an RDD which contains the numbers from 1 to 4, and we want to multiply every element by, say, by 2. So, okay, so an example of a transformation is the map function. What it does is it translates an element into another element. Okay, so map is a transformation that runs the function that you provide as argument against each element in RDD. Please note that the function map takes another function as argument. It takes another function as argument, which it is going to execute against every element. Okay, so if you have 4 elements in your RDD, it's going to execute your provided function 4 times. Okay, so let me show you an example here. So let's say we have defined an array from 1 to 10,000, then we parallelize it, convert it into an RDD, and then multiplied. We defined a function called multiply by 2, and then we tested the function multiply by 2, and then which is working fine, and then we called map function on our RDD nums with multiply by 2 as argument. Okay, and here the value dbls is another RDD containing containing the result of nums.map. So dbls.take returns the dbls.take actually executes the entire process. So let me show you here. Let me show you here. Okay. So I think this is a very easy example to understand. So here we first defined an array. Okay. We defined an array. Okay. This is a local array. Okay. This is a local array, or we call it range in Scala. Then we defined the we define nums as sc.parallelize. So if you take a look at this, it's basically an RDD, just that it is parallelized collection, meaning it is a subclass of RDD, or it's an RDD which is produced by parallelize. Okay. Now we are defining this method called multiply by 2. Okay. So what is multiply by 2? You can see that is basically returning x into 2. It just This is just usual scalar function. It has nothing much dependent. It is not depending on Spark in any way. It is basically a scalar function, right? This is a standard scalar syntax where we are saying define this function with this argument, with this data type, and returning this data type. So we need, in case of scalar, we need to define the data types. All right. So just to test whether multiply by 2 is working or not, we have executed it, and it seems to be working fine. Okay, now the next thing we are going to do is we are going to call multiply by 2 via map. Okay, so what it will do is it is going to multiply every element by 2. Okay, so this function that you are passing as argument, now you can notice that here we are handing over our piece of code to Spark, right? Instead of transporting data, we are transporting the logic. We are transporting the logic. And that's the sole idea about distributed computing, right? Instead of bringing the data to you, you take the code and send it. And that's what we are doing. We are handing over as argument our piece of logic. Yes. Then my suggestion is, can we do this? As in, we could write something like this? Yes, of course. Okay. We could write something like this as well. Now, let's take a look at here. When we say take 5, it's going to display 5 records. If we say collect, it's going to bring entire data locally. Okay. When I say collect here, you see that? Okay, collect brings all of the records into a local array. We can assign it to X, which brings all of the, let's say I call it local data, right? And we could see that this one is basically usual scalar array. So DBLS was, what was DBLS? DBLS was our what was DBLS? DBLS was essentially a RDD. Yes. Okay. So you can see that 2debug string is showing us that first we did parallelize, then we did map. Okay. Great, great. All right, so we can see that we are able to execute a very simple logic that there was some data, we converted into RDD, then we defined a function, then handed over to map, and then got it done. Okay, there was a question that I missed, that what is the when to do use map and when to use flat map. If you want to convert one record into many record, then we use flat map. If you want to convert one record to another, then we use map. Yes, I'll come back to lazy evaluation very soon, Gautam. Don't worry. Okay. That's right, Minmoy. Collect basically brings back the data back from all the executors. All right, we'll go into more and more details. Let's just do a bit of baby steps and then move ahead. Okay, yes, Paralyze will send it out and collect will bring it back. All right, now let's talk about some more transformations. Okay, there is another transformation provided to us called filter. What does filter do? Filter basically applies the provided function to all of the records, and if that function returns true for a record, that record is maintained, right? Just like in SQL, when we have the where clause, and where clause is executed against every row. Similarly, your filter function, which is a scalar code, your filter function, which is scalar code, is going to be executed against every record of an RDD, and the resulting value, if the result is true, it is the record is kept in the output, otherwise it is ignored. Okay, so we are defining here an is even function. What does is even do? It basically returns true if the remainder is 0. Okay, so this one says that divide x by 2, whatever is the remainder, compare that with 0. Okay, that means the return value is going to be true if x is divisible by 2, meaning if the remainder is 0, this is going to be true. All right, so let's define this function and then see the output. Okay, I'm going to try almost everything here. Okay, so is even is there, so let me execute it on the nums. Okay, so here I'm saying where even nums equals nums dot filter is even, right? So even nums, if you take a look at it, it contains only even numbers, right? Let's say I want to just retain 20, all the numbers which are divisible by 20. So I've said x divisible by 20 equals 0, and then I call this here and then take. So you can see that all the numbers that are divisible by 20 are retained. Okay, thank you for reminding. I have pushed it to the Git repository. Okay. A question from Enmai is that does take sort by default? No, it just takes the first n record. Good. Does it make sense to you? Or should I give you the code? Let me give you this code. All right. So this here the picture is showing you the clearly that nums was an array, and isEven is the function that we have given to the filter. And what it has done is it has executed isEven with 1, isEven with 2, isEven with 3, isEven with 4, isEven with 5, and so on, right? This is supposed to be 6. Okay. So and if isEven returned true, then the actual value goes in the output. If isEven returned true, right, it is kept in the output. Otherwise, these values are ignored. Correct? Good. Now, these were quick examples of transformations. We'll come back to the transformations again in more details. Let's take a look at the actions that we have talked about. So what is an action? So transformation transforms an RDD into another RDD, right? An action causes the action. It does something. It does something. Okay. And and there's something called Spark driver that we talked earlier, but let me go back to it again. So whenever we are doing something like here, there is something called a Spark driver. What it does is it this is this is the Spark shell that we're using. So Spark shell creates a driver application which talks to the cluster if there is a cluster. So Spark driver is your gateway to the various nodes. So Spark Driver controls the creation of RDD on all the machines, okay, on the executors. So, so generally an action like take brings back the data from all the partitions. These are the partitions. Each partition is generally on one machine or an executor, and then the result is brought back to you by take or collect here. So take basically brings back the data. All right. So let's take a look. We have been using take for quite some time, so there is no need of explicitly trying to run this because this we have been running for some time. So take or any other action does the execution while nothing happens here when we are defining nums or defining map. Nothing happens, as in no action happens. All right. The other example of action is save as text file. So we have already used it. Save as text file saves the data into this directory. Okay, into this directory. All right. So that's what happens when we say save as text file. It saves the result into HDFS. Just like take or collect, save also does the execution of the entire RDD, while the transformations are just making a note of it. It's not doing filter map or flat map or other transformations are essentially returning another RDD but not giving any other thing. Okay, no action happens then. All right, so what we learned just now is that transformation is executed lazily. Transformation returns another RDD, and action sometimes return local value or may not return any other value. Action is executed immediately. An action Action essentially does the execution of transformations. Okay, now let's talk about more about this. All right. All right. Yeah. So let me go back to a few things and then we'll take a break. Quickly, those who are wondering where are the slides and where are the recordings. So let me explain to all of you. All right. This is a common question. So you can always go to say my courses. Okay. And when you see this or you see either of these, okay, you click on start. Okay, when you click on start, you will notice that here all the topics. Okay, all the topics. This is a properly curated course in which you will find everything. Okay, so here let's say this is where we are right now. Okay, so here we talk about all of these components, and then here there are some quizzes. You have to solve these quizzes. Okay, and here this is probably where we are. And in the last slide, towards the end, you will find all the slides. Okay? You'll find all of the slides. Good? Yes, feel free to download it. Okay? You can click on this link here. It'll open in the new page and you can download it. All right. So this is where, and also please note that all of the videos we have for whatever I'm talking right now, I have created all of these videos as well for you. So you can, in case you miss out on something, just go through these videos. They will be quick and crisp and would help you in learning quickly. Okay. Also, the recordings are available here. If you go back to say my courses, okay, this is where the full course, the actual assignment and assessment, everything is here. While there you will find this one, probably this one. Okay, here inside this, you'll find all the recordings. It's a separate playlist, or you can call it topic. Okay, so this will contain the recordings of these sessions. All right. So there are two kinds of recordings. One which we have done in studio, other for the actual session. Both are available to you along with the presentation. And now along with the presentation as well as these notebooks are available in the GitHub repository. Okay. Great. Great. I hope everybody is on the same page. These are all small teething issues. They will get sorted out as we move ahead in the course. Okay. We will we'll discuss the lazy evaluation after the break. Okay, so let's take a break for 10 minutes. Back by 9:44 p.m. IST. Please feel free to share the time in your own time zone. Okay. All right, so I'm back. Should we start now? All right. All right. So great. I think somebody joining. So okay. So in the meantime, let me try to check why the system is slow. Okay. As per Bintao, the system seemed to be slow. Bintao, are you on E or F? Let me try F. All right. So let's start. I think we'll have to take a look at what's going on there. Maybe at a later point. Okay. All right. So great. For now, let's see if we can continue the way it is. All right. So, okay. All right. Okay. So we have been noticing that when we did map, flat map, filter, or any other transformation, the execution the actual execution does not happen. It only makes notes of it and then returns very quickly. But when we call take, collect, or save, then the whole process gets executed. Okay? Question is, why does it happen this way? Right? Instead of instead of evaluating immediately, it is in case of transformation, it is basically making notes of what you are doing, what you're intending to do, instead of immediately executing it. Let's take an example. Let's take an example of lazy evaluation in the real life. Okay. Imagine that you have gone to a restaurant. In the restaurant, there is a waiter who comes to take your order. Say you ordered cheeseburger, soup, and a plate of noodles, and your spouse ordered soup and a plate of noodles. So you can see that there are common orders between the two. Now, the waiter listens to your orders carefully and tries to club the orders. Okay, one cheeseburger, two soups, two plates of noodles, right? Anything else, sir? And once you say that we are done ordering, Then the waiter basically takes all your orders, and chef finally is able to optimize the execution of these orders, as in the is able to optimize cooking, because soups are together and plates of noodles are together. So instead of preparing noodles twice, he's just preparing two plates of noodles, right? So this is lazy evaluation, lazy execution. The waiter has listened to all your orders very patiently, and then place the orders, and in such a way that chef is able to optimize, because the waiter has clubbed the orders together, right? Now let's take a look at the instant evaluation, the case with, say, Python, for example, or usual scalar, right? Usual scalar, if I say x equals to 4 plus 5, the value of x, okay? So if I say where or just say where x equals 4 plus 5, instead of making notes, it actually is assigning the result of 4 plus 5 instantaneously. This is this is instant evaluation. Okay, all right. So in the instant evaluation, imagine that there is this super fast waiter wearing the skates, okay, who just takes your orders and runs away. You order a cheeseburger, the waiter goes to the kitchen to get the cheeseburger even before you can place another order, right? So the waiter's attitude is, let me get your cheeseburger before your second order, right? And the soup that, so you will keep on shouting that, what about my soup? He will take the order of soup once he brings back the burger, right? That's how usually the compilers work. That's how usually the execution programming languages work. That as soon as you say something, it does it, instead of you finalizing the order, instead of you uh, i- instead of you saying that, okay, I'm done, do it now, take all of my orders and do it now. Instead of that, the waiter is basically running to the kitchen as soon as you place the order. All right. So this is instant evaluation. Instant evaluation, the things are happening. So which one is more optimized from your perspective? The instant, this waiter or the previous waiter? Correct. So previous one, even though the previous orders look very lazy, but the previous one is actually far more optimum, right? That's exactly the reason why the lazy evaluation was done. Because mm, this approach of taking the orders instantaneously is great if individual order is taking very small time, right? This approach is great if the individual order is taking very less time. This approach is not good if there is a scope of merging multiple orders together. If the kitchen is far away, if the kitchen is far away from the table, this approach is not right. Correct? In the similar way, if the work is being done by multiple machines and our data is far away on multiple machines, then this approach is not right. Okay? And that's exactly the reason why the newer systems such as Spark or TensorFlow, which we're studying in case of deep learning, will be studying in case of deep learning, both are lazy in evaluation. Most of the usual programming languages have instant evaluation. As you type, they give you the output. It doesn't wait, it returns immediately and gives you the output, right? So this is, and the lazy evaluation is every time we are calling an RDD, action on RDD, entire RDD must be computed from the scratch. Every time in this example, in these example, every time D gets executed, this line gets executed. When we execute count, what all will get executed? Tell me. When we run this count, count is another action. Count counts the total number of lines. That's right. It will, so uppercase line depends on few lines depend on lines, and lines depends on this text file, right? So ABC, the three statement will get executed. Okay. Gautam's question is, even languages like SQL, PLSQL are instant evaluation. Yes. Just that when you are defining a view, that is lazy evaluation. Okay. Because when you define a view, you're just defining a query. It's just making notes of the query. It's not executing the query right away. Great. So when we call a transformation, it is not evaluated immediately. It helps Spark optimize the performance just like our first waiter. It is very similar to Pig or TensorFlow. Instead of thinking RDD as a dataset, you must think of it as the instruction on how to compute data. All right, let's take a look at this. Here we are defining a function map1. This is our function. There is another function called map2. And what we are doing is we are first loading lines from some files, calling map1, then calling map2 via map, right? So lines get translated to lines 1 get translated to lines 2, and when we call lines2.collect, all of this is executed, right? And internally, this kind of a code gets clubbed together. Map1, since they are in the sequence, it Spark does many such optimization. It basically is combining these two statements into a single function. Okay, so there are many optimizations that are done by Spark for you under the hood when you have a sequence of transformations. Okay, a question from Bhuvan: what is a TensorFlow? TensorFlow is a function or a framework or a library which is essentially for doing the heavy computation as required by deep learning or the neural networks in machine learning. So TensorFlow is a library by Google for machine learning and deep learning. What's the difference between take and collect? Collect brings all of the records while take brings couple of records. Okay. So usually we use take instead of bringing all of the records. All right. That's right. Thank you, Gautam. That just shows that you're paying attention. Good, great. Thank you. All right, so now you can get the idea like what kind of optimization Spark is doing for you. Let's take a look at something called lineage graph. So when we are defining these transformations under the hood, Spark is kind of preparing this lineage graph. Spark is kind of preparing this lineage graph. Okay, so when we are defining, say, particular RDD here called lines, we set sc.text file and we set some file. What it is doing is it's creating this kind of a graph. This is our node. Each RDD is represented by the node, and this arrow is represented by the function. Okay, so this is the first node in the graph. Okay, then we define few lines equals lines dot filter. So few lines is depending on lines and the operation is filter. Yes, it is same as directed graph. It's called DAG, directed acyclic graph. Okay, it doesn't have cycles and it has directions in the edges, right? So few lines can be created. Few lines is created from lines by using a transformation called filter. Further, we have another RDD, uppercase lines, which is few lines dot map, few lines dot map. Okay, then we have lowercase lines, and we are having, again, this one is depending on few lines and map some function here. Dot 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 means, so we are going to write some function here and so on. So you can see that if we call count on uppercase lines, if we call count or take or collect on uppercase line, this part of graph, is going to be called, right? It will first evaluate this, then this, and then this. This part of the graph will not be executed. If at the later point of time, if the next statement is lowercase line dot count, then this part of the graph is going to be evaluated. All right. So this is the lineage graph. Okay, it's a directed acyclic graph, DAG, and DAG is nothing but, whenever we are creating a dependency graph, it's always a DAG. Whether we are defining our project, all the dependencies in our normal project, all of that is a directed acyclic graph. It doesn't have cycles and there is a direction involved. A question from Gautam. If so, how much? Okay. A question is, RDDs are stored in memory, right? Now you can see that unless this is executed, unless a count is executed, how much memory will be used by lines, few lines, uppercase lines, or lowercase lines? Anybody? Unless we execute uppercase lines dot count, will this be any much? It will be few bytes because it's like pointers, right? The memory will be done during this count process. Every time we call count, it's going to execute the entire process from the beginning till here. Okay. During that phase, during the count phase, during the count execution, the memory will be a function of total available memory on the machine. Okay. Probably it will be approximately 60% of the total free memory allocated to the Spark process. Okay, that's the kind of memory will be dedicated for the RDD's data. We will go into exact memory, exact memory dedicated to various parts at later point of time. A question further is, so memory is built during action phase. Yeah, memory is used only in the action phase. Okay, so here we have just defined an object called lines, then few lines, then uppercase line. This will be hardly in, like, maybe this is say 10 bytes, 10 bytes, 10 bytes, and 10 bytes. Okay, maybe 40 or that kind of bytes, not more than that. Okay, and yes, yes, you can say that these are nodes. These are not really the actual data. So we can say either nodes or placeholders. So each transformation gives us another object that's basically a node saying this is how this will be created or calculated. All right. So this graph is what consumes a memory. This one, the graph contains a pointer to the parent and the information about this and the variable dedicated to this. So three variables, that's all. A question from Raghu. So how is memory released after action? As soon as the work is done, the memory is delocated. Okay. After the work is done, the process is delocated, then memory is done. Question from Manoj. Any relationship between total size of RDD and combined memory of various nodes? Um, all right. Also, please note that if the data is not fitting into the memory at any point of time, Spark will basically start reading record by record from the disk and will not load much data into the memory. Okay. So it will push everything into the disk. It has been designed in order to operate on really, really humongous data. So it just uses the memory in order to make the process faster. If the memory is not available, it will work well, just that it'll take much time to load data directly from the disk. Okay, I think that answers Gautam's question. All right. Question from Rose. That is transparent to the user, but it might be slow. Is that correct? Yes, that's right. In case it's reading every record from the disk and there is no memory available for Spark to optimize the work, then what it'll do is it'll be little slow. Okay. A question from Michelle. If disk runs out of space, will there be an error? So honestly, when we are running any of the processes, if disk runs out of space, there would be problems. Reason being that the cache, if it is trying to put some data into the cache or into the memory, and it is not fitting into the memory, so it will temporarily really create some file in the disk to keep the data temporarily. And if that is also not available, then yes, it will throw error. Good question. Question from Raghu, just a deviation. Isn't it same case with Hadoop MapReduce about using memory? Okay, good point. Good point, Raghu. So in case of Hadoop MapReduce, I wrote a good answer for this, and uh, that why is, I think this I should say, why, what is, no, the question was, should Hadoop be written in Scala? Is it there somewhere? Not this one. All right, so probably somewhere I had written. I'm not able to allocate it. Okay, let me just give me a second. I think I'll be able to. All right. This is something which I wrote. Okay. So basically, the main difference between Hadoop and Spark in case of um, the main difference between the two is basically the design choice. Okay. In case of MapReduce, the MapReduce were designed for petabytes of data. And the main assumption in case of MapReduce was do not cache anything. Do not cache anything. Okay. And the second design choice in case of MapReduce was that every job has only one phase of sorting, meaning there was map and there was reduce. Okay, we couldn't have a system like multiple MapReduce in a single job. Okay, so that was another reason. And instead of very generic two operations like map and reduce, Spark provides many things like filter, flat map, map, and so on. Okay, so those are the main differences. I think this would help you um, answer the question that you're asking. All right. So in case of Hadoop, the memory assumption was that we won't cache anything at all. Okay, the at most we were caching a single record. We were caching only a single record. Okay, at most. That's what we were doing in Hadoop MapReduce at a time. Okay, Tanmay, did you get the link? I shared the link of Quora. Uh, a question from Gautam. One question, very generic one. What is the responsibilities of big data architect in this context? Big data architect is supposed to solve the big data problems, whether it is related to storing the data or processing the data. So this course actually makes you acquainted with the entire portfolio. Okay. So whether it's a big data engineer, developer, or architect role, this course what we're learning will be making you uh, ready with all the skills. All right. So big data architect is responsible for end-to-end big data architecture. All right. Deciding which tool to use and not. Okay. As well as along with writing code. Also, these definitions are very vague in most of the industry, and one should live by the thumb rule. Okay, this is something we always followed at Amazon. We live by the thumb rule that all of us are engineers. We should be capable of solving end-to-end problems instead of only part of the problems. Okay, therefore, understanding the entire stack, the understanding solving the end-to-end problem is something that we all should aim. Okay. A question from Myanmar. Actions must be used frugally to avoid slowing down Spark processes, right? Or will Spark create an optimal plan itself when we make those mistakes? A very, very important question, Myanmar. And thank you for this question. I mean, the question Myanmar is asking that what if we end up calling collect too many times in our script? What if we end up calling count multiple times? Will that slow down? Yes, it will slow down. And you will be amazed to know that one of the somebody I was consulting, one of my ex-student, he was basically before attending the session, when I looked at his work, what he was doing is he was calling the the actions just too many times. Okay, and the result was that his program was around 1,000 times slower. okay, around 700 times slower. All right. So we will learn that part. We learn those optimizations, and those optimizations are the heart of what we are trying to do. Okay. So we will go over those problems, and so the main optimization is with respect to the transformations. There are many things that we have the knob on. There are many things that we control, or we basically change the setting of. Okay. And we will learn those all optimizations as we go ahead. All right. Great. Great. Very happy to see the set of questions. Keep the questions coming, and that will be basically the way to learn. All right. And this is a very important part because knowing that there is a lineage graph and knowing that there is map and flat map does not solve problems. What solves problem is understanding how to build the entire logic. Okay. This one basically serve as, note to yourself that this is a lineage graph, and make sure that we don't call action too often. And we will see that how we avoid the total number of actions. Okay, great. All right, a question from Gautam. In Oracle, we use data optimization, and in Hive, we use data partition mechanism for optimization. There will be many, many things that we could optimize in case of Spark. And that's main reason why people prefer Spark over MapReduce, because it gives you far more control over the exact execution. Okay, now the let me just go over a few more transformations back to the going over the transformations. So there was a transformation called flat map. It converts one record into multiple. Okay. So for example, imagine that lines RDD had two records. This is a dog named Zaddy. Okay. And we defined a function called two words. What it does is it splits the data based on the space. Now, and two words basically breaks down the sentence, this is a dog, into four elements. Similarly, the second line is broken into two words, and the words RDD has how many elements? It has 3 plus 3, 6 elements. So lines RDD, if you call count on lines RDD, they're going to be 2. If you call words RDD.count, you will get 6 as the answer. So flat map generally gives more record than the actual one, but that's not true because it could give the less number of records. All right. So how is it different from map? In case of map, the resulting RDD and input RDD have same number of elements, while map can only convert one to one, while flat map could convert one to many. Okay. So let's take a look at this. So lines RDD dot parallelize, let's create this, then we define two words, then we call this function, and then we say words rdd dot collect. So we will get this. So what you see is, since we used map instead of flat map, what we did was we called map. So what happened was the outcome still has two records, just that the data type of record has changed from a string to array. The, the record has been changed from string to array. So that's the difference when we use map instead of flat map. Okay, is it clear to everybody? The difference between map and flat map? So what if we used map instead of flat map? This is basically, map can never increase or decrease the total number of elements in the resulting RDD. Okay, if there are n records in input RDD, there'll be only exactly same number of records in the resulting RDD. All right. So this is what happened when we used map. There are total of two records, Instead of 6 records, total of 2 records, each record is of type array, right? Great. All right. So flat map is very similar to Hadoop's map. Okay. Those who have been from the Hadoop's background, they will notice that flat map is very similar to Hadoop's map. Why? If you recollect, in case of Hadoop's map, each map could produce as many key value as it wanted, not single key value, right? While in case of Spark's map, map could only produce one output for one input, okay? While in case of flat map, it produces one to many, similar to Hadoop's map, okay? Now, one more thing to notice is flat map can also give zero records. Okay, flat map can also give zero record. That means that flat map can also reduce the number of records. Okay, so if flat map returns an empty array, that means it has given zero records. So flat map can emulate map as well as filter. Okay, if flat map is returning no element, it is behaving like filter. If flat map is returning one element, it's behaving like map. All right, let's take a look. So here, let's say we have an array and we are saying multiply by 2. Okay, and we are calling flat map. The only big difference you'll notice here is instead of just returning x into 2, we are returning an array containing a single value. The function that we give to flat map must return an array. Here this array contains one value and hence we are able to use this function with flat map and its behavior is exactly like map, right? We could use flat map as a filter. Okay, so here we are saying that if a value is divisible by 2, return an array containing that particular value, right? Otherwise, return an empty array. So we have changed the definition of is even, the function that we defined earlier. Instead of returning integer, or instead of returning true or false, it's returning it's returning an array of integers. Okay, so is even is basically returning the array containing that value if the value is even, otherwise it's returning empty. So using this, we are able to emulate filter. Okay, so flat map is able to emulate map and filter, and that's the reason why Hadoop has only map, not filter and flat map, because using the Hadoop's map you could, because Hadoop's map is very similar to Spark's flat map, and therefore you could emulate filter or a flat map or map easily with Hadoop's map. Okay, do you want me to show you this, or you want to give it a try? All right, this is okay. Sure, sure. I'll just give it to you. All right, let me just call all the transformations here. Okay, and here we go. So you can see that here, if we say collect, you will see that we don't have to pass. You can see that all the even numbers have been given back to you. Okay. Also, if you want to just test how does isEven look like, so isEven takes one element. Okay, it returns an array. If we say 3, it'll give an empty array. All right. So the point I'm trying to do show you is that the flat map could be used in a very flexible way. A question from Tanmoy. I'm wondering how this function can be made inline. Let me try. Can I make it inline? Let me try this. Oh, this is okay. Is it working? Oh, it's working. All right. So this way you could make it inline, and let me try it this way. Good, good. So if I say X and I say this, no. Do I have to define like this? I see. It doesn't work this way. Mhm. Okay. I think this one is good enough. Okay. I'm also not able to make it anonymous. Maybe okay. This is generally called lambda function or anonymous function. Okay. Never mind. So, right. So is this clear to everybody? We're going to do a little more, some more exercises to make you more comfortable with this kind of computation. Okay. A lot of problems could be solved using this kind of computation in which we create an RDD, operate upon it, and so on. Okay. And we'll go into more details. Now, there are many functions in RDD. You must take a look at the various functions provided by RDD, such as union. We could concatenate. We could concatenate two RDDs easily by using union. Okay, by using union, we could easily concatenate the RDDs. All right, let me just show you quickly so that. All right, so this is what it does. Here. So if I say c.collect, we'll see all the records. Okay. So this is what it is. And yes. So all right, is it clear? It will not eliminate the duplicates. Okay. So if we have something like C here, again, it would not remove the duplicates. You can see that. All right, great. A question from Manoj. How can we parallelize the file that we loaded in the first example? That file is already in HDFS and hence it is going to be executed parallelly already. So you don't need to do anything. Parallelize is used in the case where you have an in-memory data and you want to hand it over to Spark. While text file is used in case your data is in HDFS and you would like to process using Hadoop in parallel on all the machines. Okay, so it Spark essentially uses Hadoop's yarn under the hood. Okay, now a question from Inmoy. What if we are reading from some other source which is not distributed? Will it still parallelize? Very good question. Yes, it will. Okay, we will see that. Next question is from Manoj. Do we set the parallelism label somehow? Yes, we do. We do. The second argument of parallelize asks you for number of partitions. Okay, so every RDD has partitions, and these elements of RDDs are are kept in the partitions, and you can find out the number of partitions by using the function get number of partitions. Okay, where is the, I think this way, partitions dot length. Okay, so A has 4 partitions. Okay, A has 4 partitions. For how can A have 4 partitions? Strange it is. Wow, so interesting. Now we can control the partitions. I'll show you. While create using parallelize, we could specify number of partitions. Okay, so partitions is the basic level of parallelism, and in that basically here we have just said that create only 2 partitions instead of default partitions. Okay, no, it's actually length. It was correct only. It has created 4 partitions earlier. Now we have said explicitly create only 2 partitions. All right. I think for sc.text file also, you could define the number of partitions. By default, the number of partitions will be a function of how many blocks does the file have. Okay. Okay. So we'll talk about controlling the partition as we go ahead. But for time being, know that the partitions the partitions is the main unit of execution. Okay, each partition is processed by one executor. Okay, each partition of RDD is processed by one executor. If you have more number of partitions, the executors number of executors will increase. All right, and the executors could be on multiple threads, multiple cores, or they could be on multiple machines. Okay, all right. Okay, so the work that we are doing, say when we are doing map, reduce, or flat map, or other operations on Spark, the work is done by individual executors. The work is done by individual executors on multiple machines. All right. instead of a single machine. That is the executor. All right, Mrinmoy, did you get the answer regarding the difference between partitions? So generally there is one executor eh, for per partition. Question from Tanmay further is it controlled by yarn? So if a Spark is running on yarn, what will happen is, based on number of executors required for any program, Spark will ask yarn that give me these many executors or these many machines on which I would like to run these executors. Okay, so Spark would request yarn, and yarn will create these processes called executors in which the actual logic will run, in which the actual logic of Spark will run. Okay, we will go into the architecture details again. All right, for time being, let's just get comfortable with the RDDs. All right, so union basically concatenates the two RDDs to give us a single RDD. All right, so imagine that we want to do the log analysis. Our input RDD is based on our, say, the entire log. We created two RDDs. One is errors RDD, other is warnings RDD. By filtering this and by filtering this, we could concatenate the two to get the bad lines. In this, the info, debug, and rest of the lines have been ignored. So input RDD, let's say, is containing the server logs. Server logs could be anything. It could be error, it could be warnings, it could be something else. So we wrote a function which would filter out records here, and these will be the lines that contain the error. These will be the lines that contain warning, and then we are concatenating them. So we use two filters, we created two RDDs here, and third RDD we created by concatenating the two. Okay. All right. The action save as text file, we have talked about this. It saves the result in HDFS, and it basically creates in the home directory. Collect brings all the elements back to you, but remember, whenever you're using collect, be very careful. Okay, be very careful. All right, because the data is going to come back to a local variable. Therefore, the data must fit into the memory. So be very careful when you are using collect. In your program, if you end up using collect too many times, and it's going to be a disaster. And this is the first thing that I look at when I look at somebody's code, which is taking too much time. The first thing I observe is how many actions are there in the code. And based on the actions, I realize if there are many actions that are happening in the single piece of code, then there is something disastrous that's happening. So collect brings all the elements back to you, and this data must fit into the memory. It is mostly impractical. All right. So collect is this. All right. Collect is opposite of parallelize. It converts an RDD into a local variable, while parallelize converted a local object or local variable into an RDD. It brings back the data to the Spark driver. Who is the Spark driver? In our case, in case of Spark Shell, Spark Shell is running the Spark driver application, which is talking to the cluster. While take is more practical, it brings only few records, or the number of records that you pass as argument to the take. It's bringing 4 records to the local array. There is a question from Supratik. Can we only save as text file? Not really. We can save as a Hadoop file, we can save in other formats, and so on. Okay. So there are all kinds of formats that you could use. All right. Now, count helps you finding the number of elements in an RDD. It also works in a distributed fashion. Can somebody tell if, let's say you have an RDD which has 15 partitions. Okay. Let's say you have an RDD containing, say, million elements, and there are 15 partitions. So when we call a.count, a.count, can that be parallelized? Can that be parallelized? Okay. How RDDs are built when it's a distributed file system. Okay. I'll come back to that. Don't worry. I'll come back to the architecture very quickly. Okay. I'll describe what happens inside in more details with diagrams. All right. Yes, Myanmar. This Spark will basically count in the individual partitions. So an RDD contains partitions. The partitions are processed. Each partition is processed in each executor. Executor is nothing but a process that could be on the same machine or it could be on different machines. Okay. If there are four executors, they could be on same machine, different machine, or they could be howsoever. Okay. So based on the availability of the resources, the executors could be running on Hadoop, they could be running on Amazon EC2, they could be running on different some other resource manager. All right. So yes, the count can be distributed. Okay. So the way it's going to work is it's going to ask all the machines, all the executors containing the partition of the RDD to give the count, and then it will do the summation. Imagine that you have this RDD containing seven elements. Okay. And it has three partitions. First partition containing three elements, second partition containing 4 and 5, and third partition containing 6 and 7. Okay. So it will ask each partition to give the count. So each partition will do its count and give the result. And on the driver, which is your Spark shell, it will do the summation of all the counts. Okay. So even the count is distributed. All right. Even the count is distributed. Now, so most of this parallelization is by default. Okay. A question from Gautam. In Spark, which one does the heavy lifting? It's the individual Spark executor who does the heavy lifting. Okay. A question from Alok. Can max be distributed just like count? Very good question. And you will learn that in this particular idea. Max can be distributed, and that's exactly where the reduce come into play. A question from Bintao. Is the size of partition 64, 128 MB in Spark now? Kind of yes. Okay. When we are processing HDFS file, it creates partition per input split. Each partition is created based on per input split. What is input split? Input split in Hadoop is created on top of HDFS block. Okay, should I take a digression here? I think there are quite a few questions related to the HDFS file. So let me just give a quick idea and then we will. So imagine that you have a big file in HDFS. In Hadoop, what happens is when you are storing one big file, it breaks it down into blocks, okay, on multiple machines. So this is say block one, each is 128 MB, okay? Each is 128 MB. Or let's say last one maybe say lesser. Let's say last one could be 14 MB because not all files have size which is a multiple of 128 MB. Let's say there is this file, this is block one, okay? This is block two, this is block three, okay? This is block two, this is block three, okay? So these are data nodes containing the blocks. Good. Everybody okay with this? So when we are storing Hadoop, files in HDFS, Hadoop, what happens is it cuts the file into blocks. And the blocks are by default 128 MB in the size. And these are raw data, as in this boundary could be anywhere, right? This boundary is sharp, as in it is exactly at 128th MBth size, okay? Now, what happens is against every record, against every block, it's going to create something called an input split. And this is called an input split. Okay. So input split depends upon what is it that we are trying to achieve. Since we are using the sc.txt file, this is where the logic comes into play. Okay, so here we are doing sc.txt file. So it's going to convert each raw block into an input split. And it will be basically the list of records, list of strings. Okay, list of strings. So each input split is going to be list of strings. Okay, list, or you can say list of lines. Okay, some lines here, some other lines here, some other lines here. Okay, this is how it's going to be. And this is called in the RDD, right? When we define an RDD, RDD is going to have three partition here, one partition, two partition, and three partition. This is for partition one. This is our RDD. Okay, then this RDD will map to this input split. This Hello, can you mute yourself? Or you want to say something?
No, actually, I got this.
Okay, don't worry. So here we go. All right, don't worry. Here, so we have got an RDD which has three partition. Each partition is mapped to some lines here, second partition is here, third partition is here. So when we say sc.txt file, this is what is going on under the hood. All right. Does it look sensible or did I confuse you completely? Alok, did you want to say something? You had unmuted yourself. I did mute you. You could either ask a question by typing. Yes, go ahead.
No, nothing. I just muted.
Okay, please mute yourself because. All right, good. There are some questions. It is again unmuted. Okay. All right, good. Thank you. All right. If you have any questions, please feel free to ask. And if there is something that you would like to say, only then unmute yourself. Otherwise, it becomes a little distracting. Okay.
It is something happening here. I don't know.
All right. Can I? Oh, you're being unmuted by yourself. I see. Okay. Okay. Here are a few questions. Let me explain again. I have just drawn everything, and okay. Now, so RDD spawns across multiple data nodes. Yes, it could be machine 1, machine 2, machine 3, machine 4, right? It'll try to be nearer to the data, okay? It'll try to be nearer to the data. If, let's say this arrow, let's say this data from here is being loaded into here, it's going to go through the boundary, it is going through the network, and therefore it's going to be really slow, okay? All right. If the data file is less than 128 MB, then it will be only on one machine. Generally, yes. Okay. That's correct, Raghu. So by defining number of partitions in Spark, we are overriding the default behavior as decided by HDFS. Tanmay's question is, where is the configuration to distribute to 3 nodes? Good question. So question from Tanmay that is it guaranteed that if a file has two, three blocks, are they going to be on 3 separate machines? Not necessarily. Sometimes what would happen is, let's say there is only one node available that contains the the all of the 3 blocks of a single file, right? That could contain all the 3 blocks of a single file. All right. So the block relocation or allocation is based on which machine is free, which machine is busy. Okay. I hope this diagram is clear to all. Is partition dynamically defined? So partition is defined at the time of creation of an RDD. Okay. And we can also control the partition using the various arguments. All right, does it make sense to you? Right. So Spark take that decision by talking to Hadoop. Okay. This relationship between RDD and the input split is done by Spark by talking to Hadoop and asking about how many nodes contain which nodes contain the blocks of a file. A question from Raghu. What happens when my file is 128 MB and I set partitioning as 3? It will basically distribute this and this. This is what will start happening. Some of this one will get distributed to multiple input splits. Okay. Sorry. In case, let's say there is only one input split, the RDD, this is where the distribution will happen. Okay, let's say there was only one input split, so this input split will be basically mapped to multiple RDD records. Okay. Question from Gautam. In Hadoop, we have master node, which stores metadata of the block. So in Spark, how can we visualize this? So here, basically, at the beginning of the RDD, it consults with the name node. Okay. If there is a name node, right, the master node, which contains the information about where are the blocks, this is consulted in the beginning, and on the basis of which it basically maps the RDD. Okay. All right. If we are loading a file using sc.text file, that file, if it's having multiple blocks, multiple HDFS blocks, it's going to load that. It's going to right? It's going to first create input splits. Input splits is basically based on your requirement. If it's a text file or it's a CSV file or it's a data file, binary file, it's based on the kind of data it is. We are going to create input split out of the raw data, and then RDD partitions will be mapped to the input splits. Okay. Yes, typically each partition, typically when we are saying transform, let me just draw here transform. Okay, we are saying here transform. Okay, we are transforming. So what would happen is, all right. So let's say we are saying transform. Okay, so what would happen in those cases is, okay, this transformation logic, this 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 transformation logic will run on multiple machine. So this will happen on machine one. Basically, it will happen on the same place where the input split is. This processing will happen on the same place where the input split is. If these all three input splits are on the same machine, then this processing will happen on the same machine. Okay, all right.
Sandeep, can you hear me?
Yes, yes, I can hear you.
Yeah, Sandeep, one question. Actually, I'm not able to understand properly the relationship between these three things, like number of nodes
Hmm.
and parallelize and RDD partitioning, right? So,
Okay.
like the question by uh, question by Raghu was like, what happens when my file size is 128 MB and I set the partitioning as 3? So, if my size of the file is just 128 MB, right? Then it is going to reside only on one of the nodes in the Hadoop in the HDFS file
Yes,
system, right?
yes.
Then how
Yeah.
does the parallelize and partitioning come into the picture? I am not able to get some clear idea
Oh,
on
okay.
that.
Yeah, yeah, yeah. Let's keep the parallelize aside. Parallelize is used to convert an in-memory object into the RDD. Okay, that's a complete different story.
Okay.
Right now, we are using the text file. What text file does is it takes the HDF file in the HDFS and then create an RDD around it. Okay, and when we say text file, what it is going to do is first it is going to when we run the process. Okay, what it is going to do is first of all it's going to locate that file. Okay, and imagine that that file contained three blocks and all these three blocks on different machines for time being. Okay.
Yeah, but actually, yeah, but if three blocks, then fine. But I want to understand the case of only one block
Hmm.
and identity partitioning.
In case there is only one block, the chance of there will be only one input split, and if there is only one input split, it's going to basically have only one partition.
Okay, right. So in that case, we cannot have three partitioning, right? So
we
that
can
was the
enforce we can force it to have any number of partitions. In that case, if we force something to have multiple partitions, what it will try to do is it will try to run these logics, each of the partition on the same machine containing our data. If that's not possible, what it'll do is it'll transport the data to different machines.
and how do we enforce that partitioning? What is the command or option?
So while calling sc.text file, the second argument we can pass is number of partitions.
Is that not the same as parallelize? I mean, I just want to
Parallelize
understand.
also has the same argument. Okay. So while we are, let's say, calling text file, we can say 5 here. Okay. So now lines.rdd is going to have lines.rdd is going to have partitions as 5. Okay. And based on whether it's able to execute these things on the same machine or different machine, it it might end up transporting data from one machine to another. Imagine that they were on the same machine, then there won't be any problem of transport. Okay, but in case this was in a different machine, it'll end up transporting to different machine.
Yeah, so but isn't that then the parallel same? Because when we were parallelizing one array, one
Yeah,
dynamic array, still we were passing the same thing, and we were seeing that number of partitions were creating according to that parameter.
right.
So
So
is
what
it
does
not that
parallel?
both are same?
Yeah, yeah. I'll explain. So sc.text file is for loading data from HDFS. Okay, we pass the argument of the file. While the sc.parallelize expect you to give actual in-memory data. So if you have an in-memory array, then you use parallelize. Okay, so parallelize and text file both are for creating an RDD. Both functions are for creating RDD. Text file is used in case we are loading data from HDFS, while parallelize is used for converting an in-memory object. All right. So
Right.
both the functions have an argument called number of partitions, which you can enforce. And
Okay.
both the functions have their default strategy of defining the partition. Text file defines the number of partitions based on the SDFS input splits, while parallelize defines the number of partitions based on the number of total cores available, right? Uh, and that's how it is generally.
Yes, thanks. It's clear now.
Okay, great. We will
So
show you more in details
I would
that.
like to add one thing here.
Okay,
So let's take, I mean, going to the same example. So if a
right,
file is of 128 MB and it is
right,
on the single node,
right,
and if we are forcing it to be a three partition,
right.
then RDD would be, I mean, Spark would, distribute that into a multiple machine and then do the computation.
No, it will try to do the computation. It will tell Yarn that please execute this logic on the same machine as the one that is having the data. But if Yarn is not able to do, or Spark is not able to execute on the same machine, then it will kind of transport the data to another machine. Okay. Question is, let me rephrase what I understood. Question is that what if the there was only one block and one input is split, and we forced that our RDD must have three partition or four partition. If individual machine is capable of running three or four executable for executors, three or four executors, then and that machine is free, then Spark will be able to run all the three will be able to process all the three four partitions, or run all the three four executors on the same machine. Otherwise it will run on another machine and you will end up transporting a lot of data to another machines.
So that means by giving, I mean, by forcing, the number of partitions, we are actually giving a overhead to the processing if it is really
Exactly.
not needed.
Exactly. So a lot of optimization is done by Spark for us, and we will learn that by default, the number of partitions are decided very strategically. Okay, and sometimes we will have to explicitly specify our partitions in the cases where we are okay to transport data. Let's say we are doing some really heavyweight lifting. Okay, let's say we are downloading the data from internet. We have a million URLs from which we want to download the data. Okay, right? So imagine this. I'll explain to you. Imagine this. We have a file. We have a file called urls.txt. Okay, that's located in HDFS. Okay, and we are saying this URL RDD. Okay, be with me on this. sc.text file, and we are saying urls.txt. Okay, and in the double quotes, correct? And we know that we have, and we know that we have, say, 500 machines which can download the data parallelly, right? So, so here, what would happen is this url.txt is having, say, 1 million records, okay? And if each one is 100 bytes, how much is going to be? 100 MB, okay? So even when we have 1 million URLs, okay, 1 million records, one URL in each line, okay? That's what it has. And now, so it's going to be, each URL is 100 bytes, 100 characters. So in total, it's going to be only 100 MB. That's just one partition, correct? So we will end up using only one machine in this case, but we have 500 machines and we would like to download parallelly all of these. So what we'll do is we will basically say we define a function called download URL, okay, where we have, I'm just going really fast here. We are saying equals, here, let's say download data. Let's say we have some logic here which is doing the downloading of the data, and then we are saying where result equals, what was that, urls rdd dot map download url, right? This is the function that we are calling. Imagine that this is what we had to do. We had to, let's say, download these URLs or crawl these URLs and parallelly, right? And we had so many machines. But here, what we'll end up doing is we'll end up using only one machine, and hence it'll be really slow. So in these kind of cases, we might want to say here that convert it into 500 parallel threads, or we can say 500 machine, each having say four executors. What is executor? We generally define how many processes can run on each machines. So this is essentially 2000 executors. Okay. While we are defining yarn, in yarn, we can say that each machine can have these many executors. Okay. So essentially there could be a chance of running this in 2000 executors. Okay, 2000 executors. That means say 500 urls 500 urls per machine, correct? That could have been really possible, correct? And but we, since it is only 100 MB, we would end up doing entire thing on single machine, right? Therefore it is better to do things like this. We can say run it on 2000 machines. Okay, so I hope this gives you an idea that sometimes it is better to partition manually.
So partitioning has to be used wisely than just.
Very wisely, yes, very wisely.
Okay, thank you.
Great. Great. A question from Binta is which, very good question, very good question. And probably this kind of dialogue is what kind of clears everybody's questions. And we all learn to answer these kind of questions. And trust me, when, let's say, you're being interviewed somewhere, this is the kind of questions that will baffle you in the interview. Okay. Great. Great. So where we were, uh, Manoj, is it clear now, your questions?
Yeah, it's clear. Thanks, Sandeep.
Great. Wonderful. Wonderful. Yes, Gautam, I'm going to show you in the bigger landscape as we go ahead. And yeah, I'll make it a little bit more clearer. I have already created the entire diagram for you, so don't worry. All right. A question from Minda is use available RDD with text file, create a new RDD with parallelize. Okay, not really, Binda. In both the cases, whether we are using text file and parallelize, we are creating an RDD. Okay, just that in one case we are loading the data from the file. In other case, we are converting in-memory data into an RDD. Okay, Alok, is your question answered? Gautam, your previous question, does replication influences parallelize? Okay, replication, yes. Again, replication helps us in parallelization. Let's say we were trying to execute on same machine, and let me go back to the diagram. Let's say here, machine 2 was not free. Okay, so it'll try to kind of locate some other machine nearer to the data, either the same data or a copy of it, and then we'll execute it. Okay. A question from Tanmoy. Executor seems like task tracker in Hadoop one. Yes, yes. So executor is more like a task tracker of Hadoop one. All right. So in Yarn, there is a concept of executor, right? There is a concept called container that has the executor. All right. A question from Alok is partition is equal to Java thread or thread? Okay, good question. So it could be a Java thread. Each partition could be a Java thread, or it could be on different machine itself. Okay, remember that your RDD contains partitions. Those partitions could be processed on the same machine or could be processed on different machines. Different process, not thread, different process. Okay, generally multiple threads are part of the same process. Yes, its process is Java process, which is called JVM, Java Virtual Machine. Okay, when we run a Java program, it launches something called it launches Java Virtual Machine, and that Java Virtual Machine runs your Java code. Okay, in the similar way, when we are going to run, say, here some transformation, it's going to process the partition. For each partition, it's going to create a Java process, JVM process or Java process, inside which your logic, whatever you wrote as map, would be run against every record. Okay. All right. Yes, I'll walk you through bigger landscape very soon. Okay, so the master is the executor is basically a process, a Java process. It's not necessary. It's not really a thread. It's a Java process. Okay, this process could be on the same machine, could be on different machines, and so on. All right, but not a thread. Okay, because thread means that it's the same process. So the unit of parallelization earlier used to be thread, correct? Unit of parallelization in case of most of the programming languages was thread. But when big data comes into play, the work could be on the same machine, different machines, and so on. As in when the distributed programming, distributed computing comes into play, things could be happening on multiple machines. Therefore, threads cannot really communicate across multiple machines. All right. Now, okay. Now, question from Tanmoy. Where is the master here? Who is controlling, monitoring everything like master node in Hadoop? So basically that communication is happening by Spark. Okay, by Spark, the one who is creating all of this, that communication is happening in parallel here. Okay, so yes, we will demonstrate to you the entire mechanism. right? A question from Binda is, which command can check the path in Spark, the terminal? We use pwd in Linux. Pwd in HDFS is not there. Okay. Just that note that when you are not specifying absolute path, it's going to create in the files in HDFS with respect to your home directory. Okay. All right. Good. Very good set of questions. Okay. We will go ahead with the whole landscape very soon. Oh, it's already 15 minutes past. I'm really sorry. So that's pretty much for today. We'll continue this discussion from continue this discussion tomorrow. Okay, we'll talk about reduce tomorrow. Okay, and yes,
Sandeep, one thing I want to
yes,
clear. Sandeep,
yes.
whatever the directory you showed me, like previous recording, but I am not getting this in my course.
Okay, okay. So why don't you stay back and I'll show you. All right,
Okay, okay.
all right. So yeah. So thank you everyone and have a great day. I look forward to see you tomorrow.
Yeah.
Bye bye everyone. I look forward to see you tomorrow. We'll continue from reduce. All right.
Okay.
All right. Okay. So can you? I'm sharing the screen. I'm letting you share the screen. You can go ahead and share the screen.
Okay. Shall I do now?
Yeah.
So, so here I am, Sandeep, and
Mm-hmm.
so if I, where is my, just 1 minute.
Mm-hmm.
So here I am going this one, my course.
It's not shared. It's not shared yet. Could you share again?
Oh, sorry. Yeah, now you are able to see it.
Yes. Yes.
So here, when I go this one, my course,
Mm-hmm.
so I am getting this one because I
Okay.
enroll this course.
Okay. No, there is some problem in the configuration. All right.
Okay. So once I do the start, I'm getting only one here. If I do this, only one session. This session I'm getting, not the other
Okay.
thing.
Okay. I'll just see if I can do that. Okay. Your ID is which one?
Alok IT 862392.
Okay. Okay. I got it. Okay. So you are in the BDHS ILT 26. Okay. BDHS. Okay. Can you try now?
Yeah.
Refresh it.
Okay.
Okay. So
Yeah.
first one, try.
Mm, yes.
Okay. Great. Great. All right.
Which one? This one I have to go.
So basically, here is the course overview. Okay.
Okay.
And you have gone for both, right? Big data with Hadoop and Spark, right?
Yeah,
So
yeah.
it starts with the introduction, then lab, then Linux basics,
Okay.
and so on, right? Go down. So there's a full Hadoop ecosystem. I'm just wondering, Alok,
Yeah.
we are kind of towards the end of okay. Shankar also, could you wait for a minute? I'll just finish this and then fix your problem. All right. Now coming back to you, Alok.
Yeah.
So my question to you is that, see, we have already finished till here in this session. Go down, go down. Um,
Okay.
yeah, up to say we are here actually on 20th topic in this. Okay.
Okay.
Okay, so although it would not be difficult to catch up, okay,
Okay. Okay.
it would not be difficult to catch up. You can actually just finish the Scala and Spark both these 19 and 20 topic, and that would help.
Okay.
Okay, and as in my question to you is, this is what you wanted, as in you wanted to join in the current running course.
Yeah, actually, I talked to Abhishek. So
Okay.
I asked him like if I join the big data and with Hadoop, like which is going to start on 21st Jan.
Mm-hmm.
So shall I continue with this current this running this Spark
Mm-hmm.
session? He
Mm-hmm.
told, yeah, you can join both. There is no problem because
Mm-hmm.
I am little bit new. Everything is new for me. So I
Okay.
thought ki if I join, start now only, so I can do the two times. So I will get more confidence into that.
Okay, okay, that's okay. That's
Yeah.
okay. All
Yes.
right. So yeah, I would suggest that you go through one. In the My Lab, there was this learn section that
Okay.
makes you comfortable with the entire thing, or you go through one is lab overview. Lab overview is kind of important.
Okay.
Okay, lab overview in which it walks you through the entire thing.
Yeah. Yeah.
Okay,
Yeah.
and go down. And then the Scala and the Spark both. 19 and 20. 19 and 20. Okay.
Okay. Okay. Okay.
These two things you should go through, and that should be good enough.
Yeah. Yeah. Tomorrow I only go through it
Okay, great,
before.
great.
Yeah.
All right. Thank you.
Thank you. Thank you, Sandeep. Thank you.
Okay, all right. Bye.
Bye.
Okay.
If he's
Um,
typing to
Sandeep,
something.
shall I share my screen? This
okay.
side to this side.
Yes, Shankar, go ahead. Yeah.
I'm leaving now, Sandeep.
Okay, okay, Alok. Yeah.
Thank you. Good night.
Good night.
Are you able to see my screen, Sandeep?
Yes, yes, I can see.
If we see, if I go to my course, I could
Okay.
see only that 3rd December.
Okay, 3rd December. Yeah, go into that again. Again and go into that. Yeah, actually that's just two level thing. In that, if you click on yeah, this one, you
Okay,
get
okay, okay.
okay. Yeah,
Thanks, thanks.
all right, wonderful, great.
Yeah,
All
Sandeep, I have one
yes.
question. Like, say, like my profile was totally in testing. Okay, that the data
Okay,
warehouse testing.
okay, okay,
So I am trying to convert my profile into Hadoop development.
okay, okay.
So I'm not feeling that much. I'm not feeling that much difficulty in learning in Scala, but I am totally in SQL part only.
All right, all right, all right.
So
Good, good. If you are okay with so far, right, it'll be good. But I would suggest that the Hadoop part, right?
yeah,
The Hadoop part, I think you should just take a self-paced course for Hadoop part and finish that parallelly.
yeah.
Okay?
I think already I'm learning that Hadoop ecosystem from. I think you might be known that wisdom trainers like he's a trainer is Vivek.
Okay, okay,
I didn't that he's a trainer in EduRec also, but I learned that ecosystem. But
okay,
I
okay.
wanted to learn Spark based Scala, so
All
I
right,
joined
all right.
and enroll this course.
Okay, okay, great, great, great. All right. Wonderful, wonderful. Cool. Then you will be able to do it. All
Okay,
right.
okay. Thanks, Sandeep.
Okay, Shankar.
Yeah.
Yes. So somebody was asking about current directory in Spark. I found yes. So generally the user directory is where the data is, so you can find that. All right. Thank you, Vidya and Manoj. Yeah. Any other question you have for me?
Yes, Sandeep, I have one question. I am pinging you.
Yes, yes, go ahead. Okay, so somebody was asking about this. Okay, go ahead. Yes, I think that answers Binta's question. So basically, this is basically your directory in HDFS. Okay, your home directory in HDFS. Okay. Manoj's question, any chance of getting engaged in some live projects? Okay, okay. Sure, sure. I have that, that thing in my mind already. Okay. So I'll connect. Okay. Okay. Great. Great. Thank you, everyone. It's wonderful to have you all in the session. Bye bye. Have a good day. I look forward to see you tomorrow. All right.